Okay, this is take two, so that's fine. This is about finding files. Some of my examples were weird, so I'm going to do this. But I think actually I've been looking at the PowerPoint deck or whatever, the slide deck. I like this better. This is just the textbook. I think it has. I mean, both are okay. You can use both to like learn, like give an overview of what you're reading. You want the detail here, right? But it's also good for an overview because the figures are good. So the tables and figures and stuff. That's why I brought up the ebook. So this is the finding files, and let's just talk about the ones we need. We're going to talk about are locate, find, where is, which. I think that's about it. Actually, there could be some more, but those are the main ones you're going to be using. So and again, I just like showing you the examples and maybe talking about what's going on, and also maybe getting some special insight if I have any. So the way locate works is there's a database that has locations of common like apps and utilities and stuff. So it's maintained as an index so that when you use locate to try to look for something, it responds very quickly. So if I want to see where GCC, the GNU C compiler is located on this computer, I can type locate GCC, and it shows. Here's the problem with it: it does a pattern match. So anything that has GCC in it is going to be returned if it's stored in that database. So this is for files, commands, configuration files, whatever. It's not just the commands. It's just anything called GCC. Now, you saw there's a bunch of garbage. This happens a lot with locate and find and some other things. So what you want to do is type shifted backslash, which is above the enter key, to create a pipe. That's what this is. You might have seen pipe in previous classes. I'm not sure what you guys have been exposed to, but it's like half of an OR in your programming languages, right? Anyway, pipe the output of the locate command with its argument, the command line argument GCC, to more, for example. So what this will do is, instead of taking more from like the file system or a file, it takes the file it gets instead as a stream of bytes coming out of locate. So I won't go into detail about processes and standard in, standard out, and redirecting the out from one to the in of the other, and blah, blah, blah. We'll talk about that later. I did really quickly just now, but we'll do it later in more detail, I'm sure, because this has to be a topic that's covered. When we talked about named pipes earlier, it's kind of related to, not the same thing, but not exactly the same thing, but not the same context. Anyway, so this allows you to like just scroll through this a little easier, so you can find all the things where GCCs are, right? If you like have a program, there's a program somewhere on Linux called, I don't know, foo. Right, you can do that. If foo, here's the thing, foo actually you got footbridge and other matches on foo. Actually, I don't know. I don't use locate a lot, actually, so I don't know all the different ways you can. Yeah, that didn't help there. I'm sure it probably uses regular expressions in some way or another, though. I have to think, what are the borders of lines? Regardless, you do want to type this to something like more, usually, to look for the thing that you need. So that's GCC, and let's do foo. So footer, there's a lot of footers and stuff that are going to come up. But what I never finished saying is that foo is used usually as a generic function name. It's just an example. So you would say foo of blah, 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 just to show how a function is structured or something, because you don't care about the name. Sometimes variables will be called Fred, Wilma, Barney. Like, there's some traditions for this kind of stuff. Back on track. That's how locate works. Locate works with a database, like I said. So if there's some reason you think the database changed, maybe you installed something you think should be found in locate, you can update DB, but you can't do it unless you're in admin, usually, probably. So you might want to do that just to make sure the database is up to date. But I think it runs during the startup. All right. So find is another way. So what find doesn't have a database. Find will recursively check the whole a tree that you give it. So remember I was talking about trees earlier. Again, it comes up. This tree structure is very useful for recursively traversing something, anything. You have it a lot. If you hear binary search tree, that's something you use a lot in programming. It's a data structure that makes things really quick to search. And it exploits this whole recursive nature of trees, the fractal nature of them. We'll talk about that more later maybe, but that every subtree of a tree is a tree itself. So yeah, I just want to emphasize that's why this works really well. It's find is something you can do because of the tree structure, but that's the last I'll say about for now. The syntax of find is find the root of the tree you want to look at. So the directory that you want to start in is another way of saying it. So you can give it the root of any tree in this file structure, but that means typically, like say, I'll give you a real simple example. Let's find starting at the current directory. So that's dot, and then the thing you're looking for. So name, and I know there's a hi.c, which I shouldn't use file because I don't know where it is, right? But I do know it's here, so I use tab completion. But anyway, that shows me all the locations. Starting at the current directory where you can find hi.c. If I wanted to look for all the GCCs, there's none here, right? But I know they're on the computer somewhere, so you can. I recommend not doing this normally, but this is an example. Starting at the root, at the very top of the file structure, the very top of the biggest tree you have, or the very bottom, however you look at it, the root. Now, what you'll notice is a bunch of permission denied, because what it does is it uses the find command to like change those directories and look through them recursively. It goes down one all the way to the bottom and then comes back up and to the top. Well, it comes back up to first search. It would come up at one level and then go down again. And it would keep doing all the ones on the bottom until it finishes and then goes up a level and does everything. And eventually it'll move sort of like left to right. I need to give you an animation probably to make that make sense, but it's recursive. If you do sudo on this, you'll see you get better results. In this case, when you do find, it's actually looking for files called GCC, not patterns in the file with GCC in them, but it's looking for a file somewhere that's just called simply GCC. That can be more useful sometimes. And you can see GCC, by the way, it's the GNU C compiler. It's typically the one you'll use to compile things, like, for example, hi.c. What does hi.c do anyway? Because there was no output when I used it earlier. It does. It's not main's not finished, so it's not going to output anything. But I can still run it. It doesn't do anything. Anyway, that's how find works with a name. There are other things you can use, but again, you always want to start as low in the tree as you can, because find can take a while sometimes because it isn't indexed. It's not a database. You saw that it worked pretty fast with GCC. It's going to depend on your computer and the size of the struct and how many hits you get or whatever. But it's going to be slower than locate on average. That's for sure. But another option would be like the example in the book is this one, I think. Looking in the var directory for everything that's above a certain size. So it was 4,096 kilobytes. 6K. These are things you have to look up the manual pages. You probably want to do a sudo because var might have protected files in it. And there's actually nothing in. Is there nothing? I know there is actually. Starting in var, size above. I just did this earlier at work. Let me see. Here, here's one. Let me show you. Here's one thing you can do. You can do history, grep, find. Let's see. What's one of the ones I did? Oh, plus. You gotta have the plus sign. So this is where you look at the manual, right? So if I want to execute 2,403 in my history, I can do that. Bang 2,403. And that shows you. And that was permission denied because I didn't sudo. So it was sudo. There we go. Now, that's a lot of results. So you might want to pipe it to more so you can scroll through and look at all the different results. But whatever. I think you get the idea. The reason why I said I was going to start using the ebook instead of the PowerPoint deck is because it has more tables like this one. This is a great table that shows you all the switches you can use with Find. So it's not just name. There's all kinds of things like with when it was updated, or inodes and all kinds of things. There's the size, the type of file it is. So character files, directory files, named pipes. Those file types we talked about in chapter 3. So you can mess with that if you want. 10 minutes. I can never make these videos short. I'd have to make it one video per command or something. Like, it's just impossible. There's a lot of overhead and uploading and making sure it's right and linking it in your class. So I'm not going to do that. So which will tell you when. Okay, let me show you. You know, remember I typed GCC before, right? Bang GCC. Which GCC was that? Because if we remember locate before, I think we located a bunch of different ones, and find as well. There were a bunch of different GCCs. Which one is it using? Which? That's which GCC. The way this works is it looks in your path environment variable, which I can't remember if we've talked about already, or we're still to talk about. But the way the path works briefly is that whenever you type a command like GCC, it looks left to right there and the first one that it hits is the one that it executes. So it's yeah, I don't know why I did GCC there, but it looks for the first thing called GCC, this executable program in that colon separated series of directories. So the one that it found, the first one that it found was user bin. User bin, this one right here. If there had been a GCC in one of these earlier ones, and I checked earlier, there's not, then it would have done that instead. This is why you don't have dot in your path, because there are places that are open up to the whole world, say the temp directory, and they can name something ls in there, and you type ls, and if dot's in your path, dot meaning the current directory, if it finds an ls in the current directory, it'll execute that instead. So that could be like giving somebody root access or deleting all your files or something. This is why we do ./a.out, because dot's not in our path. And the a.out is there's no a.out in any of those other places, probably. If we put one there, we would do that one instead. So you gotta watch out for that too. All right, where is the GCC that I'm using? It tells me well, not the one I'm using, but it tells me all the different places where that command is, not just anything that's got that pattern or anything that's named that file. It's all the executables that are called GCC and where they might be located. So let's see if this makes sense, because user bin GCC was the one that we're using, right? It's the first that shows up. But there's also a user lib GCC, which is not in our path. User bin, so it's not the path. I'm wrong about that. But it's user bin x11 GCC is not in that path. So there are other GCCs that you could be using. I don't know why there's a gun zipped one too. So that's kind of weird. But I guess it is actually. What does it look at? It should be looking for the executable, I know, but maybe a zipped up one is also a hit. All right, so binary source and manual page files for a command. So for a command, so it's all related to that command. It's about a command. It's not just a random file called GCC. All right, that covers those location-y kinds of things, and I'll talk to you next about linking file, kind of, very short because I already covered it.